Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In my last lecture, we have learned that integration and differentiation are inverse process of each other. That is, if we differentiate a function x cube, we will get 3x square as its derivative. And if we integrate 3x square, we will get x cube as its integral or antiderivative. Now, today we will do some questions from your textbook exercise 7.1, and our first question is find antiderivative of cosine of 3x. Since a cosine function is a derivative of a sine function, that means if we differentiate a sine function, we will get a cosine function. That implies sine function is antiderivative of cosine function. That means if we integrate a cosine function, we will get a sine function. Now we use this concept to find antiderivative of cos 3x.
To find antiderivative of cos 3x or integral of cos 3x, we put y is equal to sine 3x. Now differentiate y with respect to x. We get dy by dx is equal to cos 3x into 3, or dy by dx is equal to 3 times cos of 3x, or we can write 1 by 3 times d by dx. Now y is equal to sine of 3x, so we write sine of 3x instead of y, that is equal to cos of 3x. Since this 1 by 3 is a constant,
since we know that for some constant k, d by dx of k times fx is equal to k times d by dx of fx. Use this result, we get
d by dx 1 by 3 sine of 3x is equal to cos of 3x. Now that means differentiation of 1 by 3 times sine of 3x is equal to cos of 3x. Which further means that antiderivative of cos of 3x is equal to 1 by 3 times sine of 3x. Thus we can write antiderivative or integral of cos 3x is equal to 1 by 3 times sine of 3x plus constant of integration c. That completes the result.
Now, in our second question, we have to find antiderivative of sine of 2x minus 4 times e raised power 3x. That is, we have to find antiderivative of difference of two functions. One is sine 2x and the second one is 4 times e raised power 3x. Here we will find antiderivatives of these two functions separately. First, we will find antiderivative of sine of 2x.
Now to find the antiderivative or integral of sine 2x, we put y is equal to cos of 2x. Now differentiate y with respect to x, we get dy by dx is equal to minus times sine 2x into 2, or dy by dx is equal to minus 2 times sine of 2x, or we can write minus 1 by 2 times d by dx. Y is equal to cos of 2x, so we write cos of 2x instead of y, that is equal to sine of 2x, or we can write d by dx minus 1 by 2 times cos of 2x, that's equal to sine of 2x. Now since from this it is clear that differentiation of minus 1 by 2 cos of 2x is equal to sine of 2x, that means antiderivative of sine of 2x is equal to minus 1 by 2 times cos of 2x. Okay, so in this way we get antiderivative of sine of 2x. Now we will find antiderivative of 4 times e raised power 3x.
Since we know that derivative of e raised power x is equal to e raised power x, that means antiderivative of e raised power x is also equal to e raised power x. That is, antiderivative of an exponential function is an exponential function. Now we use this concept in this very question to get antiderivative of e raised power 3x.
To find antiderivative of 4 times e raised power 3x, we put y is equal to e raised power 3x. Now differentiate y with respect to x, we get dy by dx is equal to e raised power 3x into 3, or 1 by 3 times dy by dx is equal to e raised power 3x, or we can write 1 by 3 d by dx. Now we write e raised power 3x instead of y, so we get it's equal to e raised power 3x, which further implies d by dx 1 by 3 times e raised power 3x is equal to e raised power 3x. Now here we have 4 times e raised power 3x, so multiply 4 on both sides, we get 4 times d by dx of 1 by 3 times e raised power 3x is equal to 4 times e raised power 3x. That further implies d by dx, it is 4 by 3 e raised power 3x is equal to 4 times e raised power 3x. That means derivative of 4 by 3 e raised power 3x is equal to 4 times e raised power 3x, which further means that antiderivative of 4 times e raised power 3x is equal to 4 by 3 times e raised power 3x. Thus we get antiderivative of 4 times e raised power 3x. Now we get d by dx minus 1 by 2 times cos of 2x is equal to sine of 2x, and d by dx of 4 by 3 times e raised power 3x is equal to 4 times e raised power 3x. Thus, we can write antiderivative or integral of sine 2x minus 4 times e raised power 3x dx is equal to antiderivative of sine 2x minus antiderivative of 4 times e raised power 3x.
Here we have used the properties of sum and difference of integrals. We must remember that integral of sum of the functions is equal to sum of the integrals of functions, and the integral of difference of functions is equal to difference of integrals of functions.
Since antiderivative of sine 2x is equal to minus 1 by 2 cos of 2x, so we write minus 1 by 2 cos of 2x, then we have minus, and antiderivative of 4 times e raised power 3x is equal to 4 by 3 e raised power 3x, so we write 4 by 3 e raised power 3x, and we put here constant of integration c. So that is the antiderivative of sine 2x minus 4 times e raised power 3x. This completes the question.
I will continue this topic in my next lecture. Till then, take care of yourself. Thank you.